So this is the 2016 problem number 2 with a calculator. So the problem says that for t is greater than or equal to 0, particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals 1 plus 2 sine t squared over 2. The particle is at position x equals 2 at time t equals 4. So the first thing that we do is graph it on our graphing calculator. So 1 plus 2 sine of x squared divided by 2. And then graph it. And so the first question asks, at time t equals 4, is the particle speeding up or slowing down? So the way you do that is for part A, you look at whether or not the velocity and the acceleration have the same sign. So we have an equation for velocity, so we're going to do v of 4. And then we're going to look for the acceleration of 4, which is equal to the derivative of the velocity at 4. And we're going to find two answers for that. So on our calculator, we just plug those in. So you go to vars y1 of 4. And you get that the velocity at time equals 4 is 2.978. And then to find the derivative, you do math 8 d of x of vars y1 at x equals 4, and the derivative is negative 1.164. And because this one is positive and this one is negative, you know that the particle is slowing down because the velocity and the acceleration have opposite signs. And if they have the same sign, then they would be going, it would be speeding up. So the second part is part B, which says to find all the times t in the interval of 0 to t to 3 when the particle changes direction. And so to do that, you know that the particle changes direction when the equation for the particle has a slope of 0. And because you have an equation for the derivative of the position of the particle, you're looking for whenever v of t equals 0. So on your calculator, you're going to set your window to 0 to 3 and graph it. And then you're going to look for any time that there is an x-intercept. So you're going to do a second trace intersect second trace 0, your left bound, and then your right bound. And so then you have an x-intercept at x equals 2.707468. And you know that because it switches from positive to negative, it does change direction. So at t equals 2.707, the particle changes direction because the velocity switches from positive to negative there. And it only switches direction if it's 0 and changes signs, but you still have to check all the times it's 0, even if it doesn't change signs. So for part C, it says find the position of the particle at time t equals 0. So in your initial problem, you had that at t equals 4, x equals 2. And so you're going to just do an integral to find the position. So 2 is the position that you have. And then you add the integral, but because you have the position later on and not the position at the start, even though you're integrating from 0 to 4 of v of t, it's actually negative because you're going backwards. So you just plug it in your calculator, 2 minus math 9 from 0 to 4 of vars y1, d of x, and you get negative 3.815. And you can also do it another way where you integrate backwards based on the problem. So you can also do 2 plus and then integrate from 4 to 0 of v of t, and you'll get the same answer. So it just kind of depends on which way you want to think about it. This way makes more sense to me because it's just you're taking the integral backwards. And then for part D, it asks you to find the total distance that it travels from time t to time 3. And so for the total distance, you are looking at the integral from 0 to 3, and then it's going to be the absolute value of the velocity because you're not really looking at the position, you're looking at the total distance. And so then you plug that into your calculator. Or math 9 of 0 to 3 of absolute value of y1 d of x, which is 5.301. And that's it.